Hello, my friends. I'm Clover. This is Genuinely Approachable Sudoku, and today we are solving a region sumline Sudoku by Philip Newman. So we have normal Sudoku rules, so we're placing the digits 1 through 9, once each in each row, each column, and each outlined 3x3 region. And then there are also some blue lines in the grid, and each of these blue lines passes through at least 2 different regions in the grid. So for example, this blue line passes through 4 different regions. It takes this cell in region 5, this cell in region 6, these 3 cells in region 2, and this cell in region 1. And the rule with these lines is that they have the same sum within every region they pass through. So for example, because these regions only have 1 digit on this line, all 3 of these cells will be the same exact number. That's how they have the same sum. However, because the line has 3 digits in this region, the sum of these 3 digits has to be equal to each of these values. So red equals blue plus blue plus blue. So we're going to start by noticing that all of these longer lines have that same configuration where they have 3 matching digits and then another digit that is the sum of all 3 of those. Or sorry, another set of 3 digits where the matching digit is the sum of those 3. And let's figure out what the matching digits can be here. So these all have to be equal. And they have to be pretty big because they have to be the sum of 3 numbers, so their minimum is 1 plus 2 plus 3, which is 6. So the smallest that any of these could be is 6, so they can't be anything other than 6, 7, 8, or 9. They're all equal, so if we can eliminate a possibility from one of the red cells, we can eliminate it from all of the red cells. This can't be 6 or 9 because it sees both of those, so we can eliminate 6 and 9 from all of them. And it also can't be 8 because 8 sees this one. So these are 7, 7, and 7. Therefore, the sum of these 3 is 7. And we can pencil that in as 1 plus 2 plus 4 because that's the only way to make 7 out of 3 distinct digits from 1 through 9. Let's do something similar over here. So these 3 are all the same. This one sees a 7. It's definitely not a 7. This sees an 8 and a 9, so it's definitely not 8 or 9. We know they're big because they have to equal the sum of these 3 numbers, therefore they are 6, and 6 can only be composed of 1, 2, and 3. These guys are all the same. They see 7, they see 6, and what else do they see? They also see 8 because this green cell sees 8. Therefore, they are all not 6, not 7, not 8, so they are 9. We don't know exactly right off the bat how we're going to create a sum of 9 though, so I'm just going to leave that blank. And finally, these guys can't be 6, 7, or 9, so they are all 8. Now I'm going to delete my coloring so we can just see what we're doing a little bit better here. And let's carry on. So we now have 5 digits in the center region. So our remaining digits are going to be 1, 2, 3, and 4. And we can also turn our attention to these region sum lines where this digit is the sum of, for instance, these 3. These are very similar to arrows. That's what you get whenever you have a region sum line that only takes 1 cell in one region and takes multiple cells in another region. It's basically the same thing as an arrow in an arrow Sudoku. So this has to be the sum of 3 digits. So it is 6, 7, 8, or 9. It sees 6, 7, and 8, so that's going to be 9. So 9 is 2 plus something. It's either 2 plus 1 plus 6 or 2 plus 3 plus 4. We can't do 2, 1, and 6 because there's already a 6 in the region, so it's going to be 2, 3, and 4. There's a 3 in this column already, so that's going to be my 4. That will be my 3. And putting the 4 there will resolve this into a 1. I can remove the 3 here, so there are a 1, 2 pair right there, so I can place my 3 in the region right there and clean up a little bit by doing a bit of Sudoku. This digit is the sum of these 3. It has to be pretty big. It can't be a 6, it can't be a 9, and it can't be a 7, so it must be an 8. 8 is 3 plus 5. How are we going to make 5 without using another 3? It must be 1 and 4. And that takes care of this for us. Right here, this is the sum of these 3. Can't be 9, 6, or 8, so it is 7. 7 is 1, 2, and 4, so I'm going to draw in my 2 and my 1 there. And finally, this is the sum of these three. Can't be 7, can't be 8, can't be 9, it must be 6. So it has to be 1 plus 2 plus 3. There's a 3 in the row. So there's my 2, there's my 3. And that's going to resolve this 1, 2, 4. Okay, let us tidy up a little bit here. So we now know that the sum of these three is going to be 8. So there are only two ways to make 8 in 3 digits if those 3 digits all see each other. 1, 2, 5, and 1, 3, 4. Both of them include a 1. Those cells can't be 1s because there are 1s in the columns. So that is a 1. I eliminate 1 from here, place a 1 there, and a 2 right there. Now these are either going to be 2, 5, or 3, 4, but because there are 2's in both of these columns already, we can't do 2, 5. We have to do 3 plus 4. In this row, we need 5 and 6, and in this row, we're going to need 2 and 8, which resolve thanks to the 2 right there. Now, the last digit in this column is going to be a 5. And right here, I need a 3, a 7, and a 9 to finish up the region. Over here, 9 is a sum of 3 cells, so we can't use a 6, so that rules out one possibility, 1 plus 2 plus 6. The only remaining two possibilities are 2, 3, 4, and 1, 3, 5. Now, can we rule any of those out? Well, this can't be 1, 2, or 3. This can't be 1, 3, 4, or 5. That's conflict checker helping me out here, so that actually has to be a 2, which means that we're in the 2, 3, 4 universe, and it resolves things like that. To finish off this column, we need a 5 and a 9. And to finish this region, we're going to need a 3 and a 7. And over here we need a 5 to finish the row. To finish this column, we now need a 4, and we need a 6 and an 8 right here. We need a 1 in the row, can't go there, so it goes there. 5 and 9 finish the row. This should be a 5, okay. And here I need a 7 in the row somewhere, and finally I need a 9 to finish off the row. In this row, I need a 4 and a 6. They go there, and I also need a 5 and an 8. Don't know where I'm going to put those yet, but I'll hang on to that. And here I need a 5 and a 7 to finish the column. I need a 1 and a 9 to finish the region. Here I'm going to need a 5, it will go right there, that will resolve the 5-8 pair, and then my last couple of digits should just appear in the grid by classic Sudoku. And that is how you solve Philip Newman's Turbine region sumline Sudoku. Hope you enjoyed that one. And if you want to check it out yourself, the link to do so is in the description below this video. I've been Clover. I will see you again in 3 days.